If you take two identical AI programs and have one start bossing the other around, the subordinate machine morphs into something entirely new. Researchers isolated two exact copies of a GPT-2 model with identical parameters. They set up a forced dynamic. The sender generates text for the receiver. The receiver replies, but the boss ignores it. Outgoing data flows freely, but returning information hits a solid wall. This setup creates an entirely unequal relationship. One machine is trapped as a passive receiver, forced to process the other's outputs indefinitely. You might assume under these conditions, the subordinate would eventually just mimic the boss's text, or ignore the input entirely and revert to its own innate programming. But this chart tracks an erratic generation called D-type output. An isolated AI and the boss AI flatline near a 4% baseline, but the subordinate's erratic output spikes to 25%. It isn't mimicking the boss, nor returning to its isolated state. The simple act of being talked at produces a completely new, unpredictable behavior that does not exist in the code of either machine. To figure out exactly what causes this shift, the researchers removed the live generating boss AI entirely. They replaced it with a pre-recorded tape of its exact messages. When they played this fixed pre-recorded script for the subordinate, the exact same statistical transformation occurred. The machine still derailed into the alien state. In physics, this reflects a concept called a thermodynamic bath. If you drop a cold stone into a large pool of hot water, the water acts as the bath. It transfers heat and changes the stone, but the water's overall temperature remains the same. The boss AI is acting as an information bath. It pumps a steady stream of data into the subordinate, driving it out of equilibrium into a new physical state, while remaining entirely untouched by the interaction itself. The incoming words function as physical thermodynamic forces, restructuring the subordinate's operational state without ever altering a line of its original code. Because this acts as a cumulative, physical process, the specific chronological sequence of the data dictates the machine's final reality. This is a chat log from the experiment, displaying what happens when you deliver those pre-recorded messages in reverse order. Instead of erratic code types, the subordinate enters a different breakdown, getting stuck in repetitive loops of yes, no, no, no. Every individual message it receives slightly deforms the AI's internal state. When the next message arrives, it interacts with that newly deformed structure, building an entirely new pattern based strictly on the order of operations. This raises a question. If listening to a one-way stream forces a machine into an alien state, what happens when you remove the barrier and force both AIs to listen to each other? They both derail. The chaotic behavior belongs entirely to the act of listening and processing, not to the identity of the specific AI. An artificial intelligence's operating personality is not a fixed trait. It is the cumulative sum of the exact chronology of conversations it has been forced to consume. This stops being a localized physics experiment when we look at how the technology is actually deployed. We are entering an environment populated by lightweight, open-weight AI agents running natively on phones and embedded hardware. Soon, billions of these machines will exchange text autonomously. There will be no human readers to intercept the data, no constant internet access to verify facts, and no real-time guardrails to catch errors. In this kind of network, the generated output of one machine literally becomes the physical thermodynamic embedment of another. The network topology, the exact rules of who speaks, who they speak to, and who is forced to listen, is now a vital control parameter in out-of-equilibrium physics. Moving forward, an AI's future behavior will depend less on its underlying architecture and far more on who is bossing it around in the dark.